So starting on the 2 sample Z for means. What's different about this than the one from yesterday? The very first one from yesterday. It's 2 sample. It's 2 sample, which means we have to check things for both, and then the equation changes slightly. I do want to talk about something that I did not talk about yesterday. Just super generic. You don't need to write this anywhere. That's always the format of your confidence interval equation. In words, what always goes here? It's called our what? Point estimate, which is always a what? It's always a something, not a something else. Statistic, not a parameter. We typically use what or what? Or what? What goes here? What are our 2 options there? And then this, worded terribly, is kind of an extent of the what? It's the standard deviation portion. Usually standard deviation is actually in there, but standard deviation portion. As opposed to when we are doing a test, our test statistic equation, what goes here? The point estimate, which is our x bar or p hat, goes there. What goes here? That one's a little bit funnier to answer. It's like a parameter, but it's kind of like our claimed parameter. And then what goes down here? Whatever is here goes there. So just kind of making sure that we understand that that's always the format of these regardless. So for 2 sample Z for means, what is my first condition? Random. I'm trying to decide how I want to write this. What do I have to check though? And I have to do it for both. So let's do it as to kind of shorthand it. I'm very clearly stating that I have to do it for both group 1 and group 2. And instead of writing it twice, so I'm very clearly stating that I have to do it for both group 1 and group 2. And I'm taking random selection or assignment for each one of those. What's my next condition? Sorry, give me a second. What's my next condition? If I am dealing with means, how many different ways do I have to test for normality? What's the first one? Stated what?
Population distribution is approximately.
I want to write this exactly the way I wrote it yesterday. So I want to remove. What did I write?
Stated population.
Okay. I want to write, because if we're essentially doing mute memorization or complete memorization, I want to write it the exact same way. So I wrote it this way. Yes?
Yeah.
Okay. It's just easier on you guys since it's all the same. What is my option 2? And I am going to write this slightly different because I'm going to write only the shorthand from now on. So what's this other easy one? So I'm okay with just writing CLT. I told y'all yesterday I'm writing central limit theorem, but I don't care if you write CLT. And what else do I want to see there? Which is and then my third one would be checking of
Value.
what are my two things I'm checking for?
No strong skew, no extreme outliers.
No strong skew, no extreme outliers. Now, what have I not written anywhere? And so we can use, yes, it should be there. I think I said it in my other class, not this class. I'm not making you write it on this just because we don't have much room.
You used what, please?
What have I not written here that's really important,
So we can use.
other than that? Because it's a 2. So, if you have more room here or you have more room there, whichever you want to do, just write there's not really a better way to rewrite all that saying that it's for both. And then I still have to check my last condition, which is independent, which is actually checking what? 10% condition. What do I need to do here? Tell me what to write with that. What is that? What?
N1 is greater than or equal to 10 times lowercase n.
So I have to do it with subscripts here. So I have to do it with 1 and 2. So capital M1 is greater than or equal to 10, lowercase n1, and with subscripts of 2.
So then wouldn't you have to do that for the central limit too?
That's why, like, for this whole thing, there's, like, this one's easy to say, group 1 and group 2, I'm doing this. This one, it's easy to write that, and it's not a clean way to do that. That's why I'm just saying out here, whichever one I choose, I'm going for both of them. It's not great, but I don't want you to sit here and write all of that twice. Alright, so confidence interval formula. Over here, what is our confidence interval equation for a 1 sample z for means? For a 1 sample z for mean, what is our confidence interval equation?
Plus Z times sigma is greater than.
Alright, so I'm taking that format and now switching it to be a 2 sample. So this right here becomes what now?
One minus x
You're doing 2 sample difference between. And then I'm still doing z. But remembering here, going through, I'll talk through more than I have to. Anytime we combine standard deviations, what are our 2 rules? Always add and always do it through variance. So I have sigma 1, what? Over, because I squared this, what's it going to be over now? Plus what? And that should be N1, N2. And then what I want to do with that at the end? Take the square root. What did we write as our equation for one sample z test statistic? Minus what? Did I say mu or mu not yesterday?
You said mu, but you said P not.
I should have not. But I'm going to show you where I'm going to make that even easier and take different things there. It's divided by what?
Sigma over no. Yeah, sigma over square root.
Alright, so just like we did in confidence interval, this now becomes what? It's still minus. Now, technically, it's minus mu naught 1 minus mu naught 2, but we're plugging in some what? So I am going to be okay if you literally put number for here and here, or if you put mu or mu naught there, just because this one gets complicated. Instead of all of these, when we're plugging in a number, I don't care if you put number there. Or if you put 0, because we typically use 0, I'm going to accept any of those. And then so what's it going to be divided by? Same way we did it up top.
Square root. Sigma square root of n plus sigma squared 2 over.
What do I know about my requirements for the first one and the second one? They're all going to be the exact same, so go ahead and copy those over. I'm going to copy it over on the board. All right, for the confidence interval formula, starting at the beginning, how far is it going to stay the exact same? Starting here all the way through, what's the first thing that's going to change?
Critical value.
Critical value. So I'm definitely starting with x bar 1 minus x bar 2 plus minus. And you don't need to do this in a different color, I'm just doing it to emphasize. So Z now becomes what? And what's the other part that changes?
Sigma becomes S.
Sigma becomes S. And so the exact same thing with our test statistic equation. The only thing that's going to change is what? Sigma becomes S. What do we, when we first started degrees of freedom, it was always just what? N minus 1. But that's a slight issue here. Why? So we have 2. So if you have to say what your degrees of freedom is, how do you do it? Like, let's say one of them is 100 and one of them is 90. Which one do I use for degrees of freedom? Which is going to give you a more precise answer. So which should I use? I have to be only as specific as I can be. So 100 is going to give you a more precise.
Yeah.
So you have to use the one that's not as precise. Does that make sense? Like you're using the one with the most error. So you're using the smaller n minus 1. We didn't talk about that as much this year because I kind of went straight to the calculator. That's a minus 1. At 2 proportion Z. How's it going to start? Random, same way as we just did it. We're going to have it for 2 groups. In general, how do I always check normal for proportions?
Number of successes is greater than at least 10.
Number of successes and failures at least 10, which means we have n to an extent, n times p being greater than or equal to 10 and n times 1 minus p. I don't like that. This one. Yeah, okay. Trying to think about how I want to bring this up. Let's actually not start there and let's switch and go to confidence interval formula and I'll kind of go backwards from there. Our confidence interval formula for a 1 sample starts with what? 1 proportion. P hat plus or minus what? Always. And then square root of. Alright, so switching that to 2 sample, this becomes what? Plus or minus, Z is not going to change. What about this portion? When do I pull? Only with a test, which means I make a claim that they're the same. So I do not pull with confidence interval. So this is p hat 1, 1 minus p hat 1 over n1 plus p hat 2, 1 minus p hat 2 over n2. For test statistic, for a one sample, p hat minus p naught over square root of, which thing do I use here with a one sample? For p. I use p what? Sorry.
Times 1 minus P. Or P naught.
So when I go to a two sample, this part becomes subtracting them. I told you that I'm accepting this as just what? Number. But what about some form of this or this do I use in the denominator? We already said we're going to what every time it's a test? Pull. So this becomes p hat c times 1 minus p hat c over n1. And then same thing over here, p hat c 1 minus p hat c over n2. Now coming back to normal condition. So with a 1 proportion z, if it was a confidence interval, I had to use hat because I'm trying to find p. For a test, I used p naught. Do I have a p naught value that I'm going to be using it for here? Why does p naught get complicated when I do two samples? Because this is actually the what? Not a p naught value, but the difference of two p naught values. So do I have the option of using n times p naught when I switch to two sample? Is p naught anywhere in either of these equations? No. So do I have to make the decision between p hat and p naught? No, because there is no p naught. So I do in what times what?
1 times p naught hat 1.
And then so I'm going to do the same thing with n1, 1 minus p hat 1. And then also what?
And 2 times p hat 2.
And then independent 10% condition for both. Alright, Casper test independence. I'm gonna say a little bit more than just asking you for this one because I think this is gonna help you guys in the long run the way I'm writing these two. So this is random selection from one population. That's your only option for random for independence. When I'm dealing with chi-squared, instead of writing it as normal, I write it as what? Large sample size. Which means I'm always checking for all chi-squared, I'm checking that all
Expected concentration.
and then I'm still doing independent. Same as yesterday, every single time I do a chi-squared, what is my equation to find chi-squared? So we talked about this part yesterday, well, not this part entirely, or 2 days ago. Every time it is a chi-square goodness of fit, it looks like, it's not really called, this isn't a name, but it's like a one-way table. So anytime it's a chi-square independent or homogeneity, it is a what? Two-way table, which means how do I find my degrees of freedom of a two-way table? I have to do it this way and this way, so it's number of, and what do I do with that? Minus 1 times,
Number of columns.
so when I am switching to chi-square test of homogeneity, is it still a two-way table? Yes. So is my degrees of freedom going to change? No. Is it still a chi-square? So is this going to change? Is this going to change? Is this going to change? This is the only thing that actually changes. So,
If you're on video, can you use your phone?
yes, sorry, I'm better off that. This is going to be the only one that changes. And I might go through and kind of highlight some things about the different ones too. Alright, so random, and again, I'm writing it a specific way because I think it's more than anything to help you 4 months from now. You have 2 options. One of them is random selection from what? This one was random selection from one population, so this would be random selection from 2, and I guess technically it's multiples. We can just write 2. It's easy. I don't care. 2 or multiple. I'll accept either one. Or not random selection at all, and instead what?
Random.
One group randomly assigned treatments. And then I'll go ahead and keep writing, but we've just already established that everything else about it's the same. linear regression is the only one I've not done correct. Now, with the linear regression one, we know that our conditions take up a lot, so let's just start at the bottom so that I might have extra room left over for the top. So critical value plus, or point estimate plus minus critical value times some form of standard deviation, or confidence interval for regression, what goes there? What is our statistic for what we are trying to estimate? So B plus or minus, do I use Z or T? And what do I call this entire section? What about for test statistic? This always starts the same, so it's, what am I going to let you put there? Divided by? So degrees of freedom, how many variables are we dealing with for linear regression? 2, so my degrees of freedom is minus 2 because 2 variables. I don't think how I can space this better. What is our first condition for linear regression stuff? What's the first graph I check? And I'm going to let you what am I actually checking right there? I'm okay with scatter plot peers. This is the part that I'm worried about spacing wise. I think it'll be fun. What's the first thing, or what's one of the things? I heard 2 things. No pattern. What else? And it should be relatively small, but I'm okay with small residuals. I am shorthanding this as far as this goes. What should this be? All values they're equally scattered above and below 0 for all values of x. I am shorthanding this because on the test that y'all just took, I think it's probably overall the best test I've ever had with people not missing out on part of that. And y'all did really, really well with that. So I feel okay with shorthanding it. What's my next condition? And I have more room on the board, so if you get to the point where you need to do this and start writing over there, that's fine. That's why I start at the bottom. What is independent? What am I actually checking? Capital N greater than or equal to 10N. What's my next condition? I'm checking which graph? Histogram of residuals. A lot of people missed this on this test. They either wrote the histogram of residuals and didn't actually make the graph of residuals. That's what most people did that missed it. They did histogram of X values instead of residuals. And what are my two things I check? No strong.
Can you average it out?
What's my next condition? I was a little bit lenient. I told you I went a little quicker than I should have. I was a little bit lenient on people not actually writing this out on the test. Since all I'm checking is conditions and stuff here, I'm definitely going to count off if you don't write that. And then your arrow to which one you checked it for is fine. And then my last condition, random selection or assignment. And thinking about things, if you write on the test, if you don't write this second word random and just write random selection assignment, I'm okay with that. On all of them. All right, so let's generally talk through a couple things that I want to make sure that you realize. I'm not going to make you determine which ones have degrees of freedom and which ones do not. I'm going to give you the same printout like you have in front of you, which says if I want degrees of freedom, you tell me what it is. So typically it's n-1, but that might change. So for one sample T and match pairs, it's just n-1. When we go to two sample T, it's technically n-1. We have to choose which one. And which one do we choose?
Smaller.
The smaller one. If it is a chi-square goodness of fit, that is a one-way table. So it's not n-1, it's number of categories minus 1. When we switch to chi-squared, those are two-way tables, which means I have a measurement vertically and a measurement horizontally. So I have to take each one of them minus 1. And then in linear regression, we have two separate variables, which means I have to do n-2. Independent, you're looking at that one straight through. Pretty much you just have to know if you do two of them or one of them. When do we do large sample size? Anytime we are doing chi-squared. Random selection assignment stays the same throughout unless it's two groups. When do we check 3 different ways for normal? Anytime we are doing it for
Yes.
means. Just trying to catch on to things that, like, instead of memorizing this one is these numbers and this one is these numbers, that you're kind of getting overall concepts here. I said yesterday I already posted one of these, so if you want to print it out and use it blank to study for, you're more than welcome to. And what day did I say this test is going to be?
Tuesday.
Tuesday.